All right, in today's video, we're talking about angles in similar triangles. Well, we have learned before that similar figures are the same shape, but may not necessarily be the same size. Similar figures have proportional sides, meaning the ratios of corresponding sides are equal. So a bigger triangle might be twice as big or 1.5 times bigger than a smaller similar triangle, but each side shares that same proportional difference. Okay, in this particular example, we're asking is this triangle on the left similar with the triangle on the right? So we have to look at the sides, and we notice that this 4 is twice as big as this 2. This 3 is twice as big as this 1.5, and 5 here is twice as big as 2.5. So they are proportional, right? So what do we notice about the angle measures? That they are the same. That's interesting, huh? Same angle measurements, even though one of them is twice as big as the other one. Okay, how about these? Are these sides proportional? So we got 4 here, 3 here. So what would be the ratio on that if we were to divide that? Well, if we get a calculator, I'm going to do 4 divided by 3, and I get 1.333, or 1 1/3. So this triangle on the right is 1 1/3, is 1 1/3. Well, let's restate that. The triangle on the left is 1 1/3 times bigger than the triangle on the right. Well, let's try these other two sides. We're going to do 3 divided by 2. Yes, well, in that case, that is 1.5 times bigger than that. So these are not proportional. So in that case, we don't have to do much more. But what do we notice about the angles? That the angles are not equal either. Look at that, 30, 35, 60, 65. So these are not equal. So if they're not similar triangles, sorry, that may not the same, right? So that's an interesting development there. Okay, so here's a little definition then. Oops. If two pairs of corresponding angles in a pair of triangles are congruent, then the two triangles are similar. So that's kind of interesting. That's almost like a converse kind of type of a definition. So the angle criterion described below allows us to determine if the two triangles are similar by observing just their angle measures. So if their angle measures are the same, then these two triangles are considered similar. Okay, so if we give you a couple of triangles and I only give you 2 measurements, then we have to find the third angle and see if all 3 angles in each one match up. So in this first triangle, I'm going to do 180 minus 87 minus 58. And that comes out to be, come on, I've got a little different. I got to clear my calculator. 180 minus 87 minus 58 equals. That comes out to be 35 degrees. So this is 35 degrees. And if you look over here, that's 35 and that's 87, which means this has to be 58 degrees. And then these some triangles really are similar, aren't they? Right, what about these two? Are they similar? Well, we got 80 and 60, which adds up to 140. If I subtract that from 180, then my missing angle over here is 40. So if I start looking around, I see I got an 80 and an 80, but I don't have a 54 in here. I've got a 60 and a 40. So we've got a mismatched angle right here. So these are not similar. All right, nice little definition there, isn't it? Okay, so Jace has constructed triangle ABC where the measure of A is equal to 53 degrees. The measure of angle B is 112. Ruthie has constructed triangle RST where the measure of angle S is 112 and the measure of angle T is 15. Are the two triangles similar? So all I need to do is take Jace's triangle measures and subtract it from 180 and see if they end up being the same as that third angle on Ruthie's triangle, or I can take the two of Ruthie's measurements, subtract them from 180 to see if they equal that 53 on Jace's. So let's just go ahead and do that. We've got 180 minus 112 minus 15 more. So I'll do that on my calculator over here. You do that on your calculator real quick. 180 minus 112 minus 15 equals 53. Oh, look at that. This was a 53 degrees as well. So this does show that the three angles of each triangle have the same angle measures. So that means that they are similar. They are similar. Okay, what's our next question here then? Well, another little definition. So, steps to finding missing side lengths. Determine if pairs of corresponding angles are congruent. If so, the corresponding angles are congruent. So if so, then the triangles are similar, and so we can set up and solve a proportion in order to find the missing side lengths. So we've done something similar before, but the first thing we've got to determine is if these are similar so that we can actually set up a proportion that will work. So if we look at these, we've got 68, 47 degrees, and 47 degrees, and 65 and 47 degrees. So we need to subtract these two angles from 180 and see if they equal 65 degrees. 180 minus 47 minus 68. Excuse me. 180 minus 47 minus 68. That equals 65. What do you know? Which matches this angle up here. And we already have a 47, so that means this last angle right here is going to be, on this triangle, it's going to also be 68 degrees, right? 47, 68, and this is 65. Okay, so we've verified that the angles are the same. So now all we have to do is find the missing side, which is right here. And if we do that, we just got to find a couple of other sides that correspond to it. So you notice this is along the side that's between L and R, J, K, K, L, R. So in this direction. So from L to R, we've got question mark. Now, if we look at the other triangle over here, the side that we're looking for would be the 10. So that's in the same position. And now we're going to just set up a proportion between, since we got that and that, now we're going to set up a proportion between the other two sides we know, which is 12 and 15. So 12 and 15. Now all that's left now is to do a cross multiply and then divide by 15. So let's get our calculator. 10 times 12 equals, divide by 15, and that also equals 8. So our missing side here on this diagram equals 8. All right, pretty slick. There you go. So let's try another one. So we know that this is 58 degrees, 61 degrees. So I'm going to do 180 minus 58 minus 61, and I'm going to get 65 degrees. Okay, so this is 65 degrees. Well, if I look over at this triangle, I don't see a 65-degree angle. Do you? Not 65. So we've had to see if they are similar, and they aren't. They are not similar. So they are not similar. So we can't find the missing side length because it won't work. Okay, if the triangles are similar, set up a proportion to find the missing side lengths. Okay, so we're trying to find that missing side length right there, if these are similar. All right, so if we look at our two sides here that are our angles, on this particular angle, triangle right here, we have 37 and 52 degrees. So if we do 180 minus 37 and minus 52, what do we get? 180 minus 37 minus 52 equals 91 degrees. Okay, so this is going to be 91. Well, how can we tell if the angles match? Well, if we look at this, we can start noticing that this side's 12 and this side's 12. We know that by our vertical angles, this side's 61. So if that's the case, and these two sides are the same, then that's going to make this a 52-degree angle. Oh, so that tells us that this is 37 degrees. So using a couple different principles that we've learned before, and it also says it helps because BX is similar to the segment MB. So these two lines are parallel. So then these are similar triangles. So this line right here, we're looking for, and it corresponds to the side between A and B. And so if we think of this in terms of alphabetical order, A, B is the first two letters of the alphabet. So according to our diagram right here, which two are in the best alphabetical order on the bottom one? Well, A and M would be, right? Okay, so that means that this question mark right here is going to correspond to the angle 12 over here, which means that 12 on this one is going to correspond to the 16 on this one. And now we can find our missing side. So 12 times 12 is 144. 144 divided by 16 is 9. So according to our calculations, this would have to be a 9, right? And so if we want to look at our proportionality, 9 over 12 would be 3/4, and 12 over 16 would also equal 3/4. So it works. All right, here's one that's a little bit different, but you kind of got a couple of triangles stacked on top of each other. So let's look at our angles. Since we've got these similar looking triangles, one on top of the other, and this one is stacked squarely on top of it, so we know that this angle right here has to equal this angle, all right? And if that's the case, then this has to be 50 degrees, and this has got to be 50 degrees, which means that this angle on top and on top here is going to be 80 degrees. And it's the case same for the small triangle and the big triangle up here, okay? So that means we can set up a proportional, or a proportion to find out our length. So question mark over 20, this number over this number has to equal, this little slide up here, 6 over, now keep in mind this length right here is the big triangle, and it has to include 9 and 6, which is 15. All right, so now when we cross multiply and divide, we do 20 times 6, which is 120. So question mark's going to end up being 120 when we multiply right there. And then we divide by 15. So when we divide that by 15, we get 8. So our question mark missing side length is 8 on that one. So when you get these pictures, they're a little bit unusual, but kind of analyze them, look what's going on, and then you may have to kind of surmise or develop a little piece of information to help you solve it. Okay, so the assignment is going to be a similar triangles worksheet. So good luck with that. Thank you very much.